Bearings and triangle problems. Here we're looking at compass bearings rather than true bearings. So it's quite easy to figure out what they mean, and I'll explain that with these examples. So we're going to draw a diagram to represent travelling 500 meters on a bearing of north 20 degrees east. Now, if we draw across, and north usually goes up the page, south would then go down, and west and east form the word we as we go across the page. So this says we start at north and then turn 20 degrees towards the east. So that's going to put us in this sort of direction. So we'll say that this is 500 meters and label this as 20 degrees. And then we've gone from the north 20 degrees round towards the east, and we've walked 500 meters. So now we have travelling 5 kilometers on a bearing of south 70 degrees east. Now you don't always need to do the whole north, south, east, west, but I'm going to do it just here. So remember, this is west over here, this is east over here. This says we start facing south and we go 70 degrees towards the east, so that's going to make us go in this sort of direction. So this is 70 degrees. So from south 70 degrees towards the east, and we need to indicate that this is 5 kilometers. 1.2 kilometers on a bearing of south 10 degrees west. So north, south, west is over here and east is over here. So starting facing south, we're going 10 degrees towards the west, so that's going to be down here. Just indicate that this is 10 degrees, and this would be 1.2 kilometers. OP starts from his campsite and walks 700 meters south and then turns and walks 500 meters east. How far is he from his campsite? What is his bearing from the campsite? And what direction could he walk in order to return directly to the campsite? So let's say that OP starts here and this is north. We know that OP walks directly south. So he's going to go down the page to this point here, and that would be 700 meters. He's then going to go 500 meters east, so that's over here, and we know this is 500 meters, and of course there's a right angle between going south and going east. So this is where he is, and this is the line he would have walked had he gone directly. So for part A we want this distance here, and we can use Pythagoras' theorem. So d squared would be equal to 700 squared. Note that the d is the hypotenuse of this triangle. Add 500 squared. So let's just calculate that. So that's going to be 700 squared, add 500 squared. So that's 740,000. And then d would be the square root of that. So we want the square root of the last answer. So 860 meters to the nearest meter. So 860 meters. So that's to the nearest meter. We now want to know what's the bearing from the campsite. So he started south and he's gone around towards the east. So if we can work out this angle here, let's call the angle theta, then we can give his bearing as a compass bearing. Now, this is the opposite, this is the adjacent, so the tangent of theta is going to be the opposite over the adjacent. So that's going to be 500 over 700. And so we can now work out theta. So we're going to want the inverse tangent of 500 over 700. That gives me 35.5 degrees to one decimal place. So he started from the south and he'll have turned 35.5 degrees towards the east. Alternatively, we could have given that as a true bearing, and true bearings are always how far we've gone clockwise from north. So in order to get that, we could do 180, take away the angle we just found, and we could give that as 144.5 degrees as a true bearing. But we've been using compass bearings in this exercise so far, so this is the answer we should give. We now want to know the direction he could walk in order to return directly to the campsite. So OP is now here. If we put north here, this angle here will be 35.5 degrees, and we know that because we have parallel lines. And we can see that the theta that we found here to be 35.5 is alternate, it's on a Z shape with this angle here. So, how would we describe this direction up here? So starting at north, he would turn 35.5 degrees towards the west. Also in this particular section we have angles of elevation and depression. If this is your eye and you're looking directly horizontal, an angle of elevation is the angle at which you'd need to look upwards to see something. So to see this yellow triangle up here, this would be your angle of elevation. Let's call it E. An angle of depression is the angle that you'd need to look down from the horizontal to see an object. For example, this smiley face here. So this angle here is the angle of depression. Romeo is measuring the height of a tower. He stands 100 meters from the tower and measures the elevation to the top as 60 degrees. What is the height of the tower correct to the nearest meter? So let's say that Romeo is here. We're not told how tall Romeo is, so we're going to assume he's looking from ground level and that the tower is over here. And then he looks up at the top of the tower like so, and the angle of elevation here is 60 degrees, and he's 100 meters from the tower, and we want the height of the tower. Now, compared to the 60 degrees, this is the opposite, and this is the adjacent. So if we think about car, tower, opposite and adjacent means we're using the tangent. So we can say the tan of 60 degrees is equal to the opposite, which is h over the adjacent, which is 100, and then h is equal to 100 multiplied by the tangent of 60 degrees, and all we have left to do is calculate that. So 100 multiplied by tan of 60, and that's 173 to the nearest meter. So we'll say 173 meters to the nearest meter. Juliet is walking along a beach. From one position she measures the angle of elevation to the top of the sand dune at 5 degrees. After walking a further 20 meters towards the dune, she measured it at 10 degrees. How tall is the sand dune? So if this is the dune just here, the height is h, and let's say from here she measured 5 degrees, and from here she measured 10 degrees. So we know this distance here is 20 meters, and let's say the distance from here to here is x. Now if we just look at this triangle, this is the opposite, this is the adjacent, so we know that tan of 10 degrees is equal to h over x. Now we can rearrange that to give us that x is equal to h over tan of 10 degrees. Now the whole distance here would be x plus 20, and it follows that the tan of 5 degrees would be the opposite, which is h. I'm looking at the overall triangle now, all the way around. So h over x plus 20, and therefore x plus 20, just rearranging, must be equal to h over 5 degrees. So what we can do is replace the x here with this. Let's put that in here. And so we have h over the tan of 10 degrees, add 20 is equal to h, I've just written 5 degrees here, and of course I meant tan of 5 degrees, is equal to h over tan 5 degrees. So bringing this over to the other side gives us h over tan of 5 degrees, take away h over tan 10 degrees is equal to 20. Factorize here, h into 1 over tan 5 degrees, take away 1 over tan 10 degrees is equal to 20, and therefore h would be equal to 20 divided by 1 over tan 5 degrees, take 1 over tan 10 degrees. And all we need to do is calculate that. So we have 20 over so 1 over, just make sure we're in degree mode, we are, tan of 5 degrees, and then we have take away 1 over tan of 10 degrees, and just so that would give me 3.47. So I'm going to give that as 3.5 meters to 1 decimal place.